Good day, I am Teacher Richard and welcome to this episode titled Heat and Temperature. So basically we will talk about heat and temperature in this video. So this lesson is based from the most essential learning competency, which is to differentiate between heat and temperature at the molecular level. So in this video, we will try to differentiate between heat and temperature in molecular level, discuss the properties of heat and temperature in molecular level, explain thermal expansion, and discuss specific heat capacity. I know that the word heat and temperature are related to one another, but in this video, we will try to differentiate the two. Now, heat is an energy form that transfers from a body of a higher temperature to another body of a lower temperature. Hence, it can be transformed. Bear in mind that heat is a form of energy, hence it can be transformed into another form of energy. For example, the geothermal energy, wherein they use the heat coming from the Earth's interior to generate electricity. Heat is produced from molecules of matter that continuously vibrate. And the unit for heat is joule, which is represented by capital J. Temperature, on the other hand, is a degree of hotness or coldness of a body or an environment, which only means that if the temperature of an object is low, then it is cold, and when the temperature of the object is high, then it is hot. Temperature is a measure of the average kinetic energy of the particles in an object. We already know that when we say kinetic energy, it is the energy possessed by a moving object. So why is that temperature is the average kinetic energy of a certain object? Take note that all objects or matter have atoms, and these atoms can get excited if they gain energy. Once they gain energy, they become unstable, making them move at a faster rate. This movement of atom is the one we are measuring in temperature. Hence, this movement of atoms will cause vibration, producing heat. And there are three common temperature scales, which are Celsius, Fahrenheit, and Kelvin. Now let's take a look at the relationship between temperature in Celsius, temperature in Fahrenheit, and temperature in Kelvin. So to get the temperature in Celsius, if you try to convert it from Fahrenheit going to Celsius, all you have to do is remember this formula. So temperature in Fahrenheit minus 32 times 5 divided by 9. To convert Kelvin to Celsius, all you have to do is to remember this. Kelvin minus 273.15, then you will get the value in Celsius. Just follow the following formulas. I know these are not new to you because you've been used to these kinds of formulas when you were in grade school. At different temperature, matter could change, and we call this as phase change. A good example of this phase change is the water cycle. Water could form into solid, liquid, and gas, depending on what temperature. Water can be in liquid form if it is around 1 degree Celsius to 100 degrees Celsius. And above it, water will turn into gas, or known as water vapor. Below 1 degree Celsius, water will turn into solid, which is also known as your ice. Also, if temperature changes, certain objects change in their length, width, height, area, and volume. We call this as thermal expansion. For example, the mercury thermometer. If the mercury inside that thermometer is subjected to hot object, it expands. That is why mercury thermometer is used in measuring. Another example would be the gaps between the cement road. Those gaps are intended to be there to prevent them from cracking during hot days. Because we all know, once a certain object is subjected to high temperature, it expands. That's why there are gaps between the blocks in the road to prevent the road from cracking. Another one is during sunny days or during summer. If you have observed that most of the cable lines are sagging down, it's because they are expanding. There is what we call as heat capacity, which is the quantity of heat necessary to raise its temperature by 1 degree Celsius. This means that certain objects will require more heat before it will increase in temperature, and there are objects that can be subjected to low heat but increases in temperature at a faster rate. For example, water has high heat capacity, which means it will need more energy before it increases in temperature. That's why water is used in some cooling system. Most specifically, it is used as a cooling system in a system unit of a certain computer. Just like the picture here. Another matter that has a high heat capacity is copper. That's why copper is used in computers, most specifically laptops, because they absorb more heat. They have high heat capacity. Those are the water and copper are both of those are used as a cooling system in gadgets. Meanwhile, iron has a low heat capacity. That's why iron is used in cooking ware, because it can absorb heat faster, making the cooking process fast and quick. Specific heat is the amount of heat necessary to raise the temperature of 1 gram of a substance by 1 degree Celsius. Now let's take a look at these examples in the table. For aluminum, it will need 900 joules per kilogram degree Celsius of energy for it to increase in temperature. Another, human body will need 3,470 joules per kilogram degree Celsius for it to increase in temperature. For protein, it will need 1,700 joules per kilogram Celsius degrees to increase the temperature of that object. That's it. I hope you were able to differentiate heat from temperature, explain thermal expansion, and discuss specific heat capacity. See you next time.